Hello, my name is Ridge Ricketts, and this is my video for coding problem set 5. This is the cipher. We're asked to decode a problem or decode something in this problem set. So we're going to pull back up to the top, and we're going to go ahead and get into it. I'll start explaining some of the stuff I have here. So in problem 1, we are asked to build the shift-directed dictionary and apply shift. So we have to fill in the build shift dictionary, says right there, and then fill in the apply shift, go over here, pull back over to versus code. So yeah, so in this, in the build shift dictionary method of the message class, I implemented the logic to create a dictionary mapping each letter to its shifted counterpart based on the given shift value. So essentially, this method ensures that both lowercase and uppercase letters are correctly shifted and just maintaining their class. The resulting dictionary contains mappings for all lowercase and uppercase letters, so is required by the question. And then we have the apply shift. Wait, where's this at? So yeah, we got build shift dictionary. And so next we have the apply shift dictionary method. And so in the apply shift method of the message class, I applied the Caesar cipher to the message test using the shift value. And the method actually utilizes the build shift dictionary method to obtain the shift dictionary. Each character in the message text is then replaced with its shifted counterpart. If it's a letter, while non-letter characters will remain just unchanged most of the time. And then the resulting string is then returned as the shifted message. Now, in problem 2, we're dealing with the plain text message. Now, for this problem, plain text is a subclass of message and has methods to encode a string using a specified shift value. Now, I'm asked to implement the methods in the class according to the specifications. So we're filling in the init, get shift, get encrypting dictionary, get message, and change shift. Pull back over to versus code. So we have 1, 2, 3, 4, 5. We have all of these right here. And so essentially what's going on here is we have this is essentially the inheritance and constructor cell. We inherited the properties and the methods from the message class by specifying the ciphertext message as a subclass. And we go ahead in the init method, we called the constructor of the parent class using the super init text. This just ensures that the parent class initializes the message text and the valid word list. And then we have the decryption method implemented in the decrypted message itself. And this method decrypts the ciphertext message. It iterates through each possible shift value from 0 to 25 and encrypts the message using the apply shift method that was inherited from the parent class. So for each decryption attempt, it just essentially splits the decrypted message into words using the split method, and it then counts the number of valid words in the decrypted message using the isWord helper function. The method keeps track of the shift value that results in the maximum number of valid words in the decrypted message. And then finally, it'll just return the best shift value and the corresponding decrypted message, therefore. These changes actually enable this class to decrypt the message using the brute force approach. All right, let's go over here. So we have ciphertext message. Moving on to our next class. So we are asked to once again fill in the methods in the class according to the specifications. We have two of them. We have init, self-text, and then decrypt message. So back here in versus code, ciphertext message. And so in this code, this snippet right through here, we import the required classes and functions um, from the PS6 module. Specifically import the get story string function, essentially to retrieve the encrypted version of the story and the ciphertext message class. And this is to create an object for the encryption or the decryption. And so retrieving the encrypted salary, we call the get string or the get story string function to obtain the encrypted version, sorry, I can't speak. The encrypted and decrypted is messing me up, version of the story as a string. And this function returns the encrypted text of the story from the file, from the story text file. And then we create an instance of the ciphertext message class. And then with that, passing the encrypted story string as an argument. And then this object will be used to decrypt the encrypted story. Now, once we decrypt the message, we call the decrypt message method on the ciphertext message object to decrypt the encrypted story. Now, this method returns the shift value used for the encryption and the story text, the decrypted story text. So, and we'll pull over here. So we decrypt the story. Now, this is just the final part. Now that we have everything together, we use this to decode the story, the text. And with that, we'll have the helper function, the get story string. So we'll go to here. And then here down here, we have the main part of the program. Now, down here, we have the decryption of the actual encrypted text. So the program ends up decrypting the text stored in the file. Actually, let's see. Yeah. So actually, like once we get down here towards the print statements, we print out the shift value attained from the decryption, um, which will indicate the amount by which the characters in the encrypted story are shifted. Now, what we end up with the actual message decrypted down here, what I've received 21 previous times. All right. Now, once again, Jack Flory is a mythical character created on the spur of a moment to help cover an insufficiently planned hack. He has been registered for classes at MIT twice before, but has reportedly never passed a class. It has been in the tradition of the residents of East Campus to become Jack Flory for a few nights each year to educate incoming students in the ways, means, and ethics of hacking. And so that's the final. I'll run it one more time. That's the final output, the decrypted message. Let it go through one more time. FX of that. All right. That's my full video for this. If I left anything out, go ahead and let me know. Or if I did anything wrong. This was actually pretty tricky to get it to actually read my um, file. I had a really hard time getting it reading my text file. For some reason, every time I try end up using this in versus code, it is always such a hassle for me to try and get that thing to work. But that's pretty much everything. Um, I guess I will see you next time. Thank you.